Is it okay now?
Yeah, much better.
Okay. Good evening, everyone. Am I audible, clear?
Good evening, sir.
Yes, Malolan, you're clear.
Right, fantastic. Okay, so let's get started. I believe the agenda for today was communicated to you guys. So we just wanted to talk to you about the, let's say, a brief description of the solution to your quiz. That was point number one. And point number two, in case if you have any queries in your assignment, we will not give you the answers to any of the assignment questions because the assignment closes on Sunday. All we wanted to do is any general queries that you might have had that we can help you with, we will try to help you with. All right. If it is within the preview of not giving away the answer, we will try to help you with that. So that is the agenda for today. So we'll get started with the quiz first. So I hope my screen is visible to everyone.
Yes, Malolan. It's a whiteboard.
It's the whiteboard, yes. Okay. So what I'm going to do is I'm going to try and solve these problems on the whiteboard. A few of them I will solve using Excel if required. But let's get started. Okay. The order in which these questions appear would depend on the question paper that you're looking at. So that is fine. I'll show you the question and we'll solve it. So the first question is where I've given you a demand curve and we are asking you two things. One, what is the elasticity for this linear demand curve? And number two, what is the saturating price, right? So two is very intuitive. It is by default the price that gives you zero demand, right? So all you have to do is you will have to take the equation, which is demand for a price is equal to 1500 minus 20p right? So that is your equation. For question number 2, all you have to do is equate this to 0. So that is 1500 minus 20p is equal to 0. So p would be equal to 1500 by 20, which will come to around 75. Okay. And there was a small error in the answer that was given to you. It said 750. All right. We will rectify that, and the mark will be awarded if you have given an answer of 75. So that is with respect to problem number 2. For problem number 1, where we are asking you the elasticity, this is a direct formula for you guys. All right. It was given in one of your videos, which talks to you about elasticity is the slope into price divided by demand at 0 minus slope into price. Okay. So we have told you that the price is 50. So that will come here. The slope is nothing but the 20 that you have. So into 20 divided by 1500 minus this will come to around 1000. Right. So this will be 1000 by 500, which means it is 2. Okay. So let's just deviate. So answer to this question is 2. Let's just deviate for a minute. Since all of you have completed BDM and we have seen a lot of elasticity in BDM, what does this imply? Is this product elastic in nature or inelastic in nature?
It is elastic.
It's elastic. And so what does that mean? What does elastic mean? Anyone?
Change in price will affect the demand.
Will drastically change the demand.
Yeah, drastically. Because
Will drastically change the demand.
Yeah.
2 times. Here will be 2 times. Two times. But in general, whenever you say elastic, it's going to be drastic change. Okay. So that is with respect to 1 and 2. Any queries on this one? These 2 questions. The practice problem. I think if you have any queries, please raise your hand and we'll get to know that. Okay. So that is with respect to 2. Question number 3 is a direct question from the contents. All right. So if you want to answer to question number 3, you will have to visit the answer to question number 3. You will have to visit week 3, the lecture on linear response curves, and at around 10:40, this discussion will happen. Okay, so just go there. So it's a direct content from your videos, so you'll be able to find it there. Okay, question number 4 is actually interesting. So question number 4 talks to you about the nature of distributions. And what is a symmetric distribution? Can someone define it to me? What is a symmetric distribution?
The mean, median, and mode overlap.
Okay. What does that physically mean?
A mirroring of the distribution will take place. Suppose if we put a mirror on a center, then it will be identical on both sides.
Identical on either side. So that is a symmetric distribution. All right. So standard normal distribution, everyone knows it's going to be a symmetric distribution. So let's take that out. I have specifically used the term called standard binomial distribution because binomial distributions need not be symmetric in nature. But a standard binomial is a symmetric distribution. For example, tossing a coin is going to lead to a standard binomial distribution, which when repeated a large number of times will have 50% of the values having heads and 50% of the values having tails, right? So that is what the word standard is very important. So if this word standard was not there, you can actually consider a binomial to be a non-symmetric in nature. It can be if the coin is biased or something of that sort. Then comes the uniform distribution. So the uniform distribution, let me just do one thing. Okay. So the uniform distribution is symmetric in nature, irrespective of the range, whether it is -1 to +1, 0 to 1, 1 to 2, or 0 to 2, whatever it may be, all values on that have an equal chance of being chosen. So the uniform distribution is symmetric in nature. So among the given options, only Poisson is a non-symmetric distribution. So that would be the answer to this particular question. Okay, everyone clear? And we have discussed all of these distributions, standard, normal, uniform, and Poisson during our lectures. And binomial we will do during. It is more common, but we have not discussed that in detail. But yes, it will be used. Let's say when you are talking about logistic next week. That 0-1 variable is going to be a binomial. Okay. So, any questions on this particular question of the quiz? No. Okay. Then comes the computationally intensive question number 5. So, question number 5 is a question that you have not solved till now, but we have shown you an automated approach to solve this problem, basically during our tutorials. All right. And that is the reason why we gave you the hint. And even after giving you the hint, once we have a question that has 7.5 marks out of let's say the 20, and a hint is given, you should know that there is something that is hidden, that's a catch that you should overcome. So you should be able to see that. Okay. So what is this question looking at? It is looking at the problem of goodness of fit, whether a theorized distribution and the population are the same or not, right? So that is the focus for this particular question. Having said that, in our tutorial videos, we did the calculations using Python, and we directly got the chi-squared value. Here what we have done is we have given you that table of observed frequencies and expected frequencies, and we want you to calculate the chi-squared statistic, which is your test statistic. And that is why we have given you the formula of how to calculate the test statistic. Now the catch is that we have told you there are 100 observations, all right? So if you sum this up, this will not add up to 100. Let me just open up the solution. Yeah. So, yeah, this is your data frame. All right. So if you see, we are talking about number of defects. So it can be 1, 2, 3, or more than 4 in the product. And if you look at the sum of these, it comes to around 82. But our sample size is going to be 100. So what does that remaining values correspond to is the question. Okay. So those are going to be, that is the catch. So those are going to fall under the category of no defects. So there are going to be 18. The same way for this, the sum is going to be 70. So 30 is going to fall under the category of no defects. So out of my total 100, this row is not given to you. I have given you those which has 1 defect, 2 defects, 3 defects, or more than 4 defects, 4 or more. This is not given, and this is what you should identify. Once you have identified this, then it's a standard application of your formula, right? So it's going to be the standard application of your formula, this formula, and you're going to get the chi-squared test statistic. Any questions so far? And that is going to be the answer. It's going to be 41.2. The actual value is going to be 41.1. So the range is going to be 41 to 41.2. Okay. So that is what this question targets. So how you calculate the test statistic? You should ensure that the sample size is completely captured in your table that is given. Okay. Any questions? No questions? All right. So once you have calculated the test statistic, it goes on to the thing of testing your hypothesis. So what I've done, what is the null hypothesis is the first question. So the null hypothesis is that whatever we have theorized is the actual population distribution. And the thing is, it is the population distribution that we are theorizing, not the sampling distribution. So the answer to this is, the null hypothesis is the population distribution is a Poisson, because that is what we are theorizing here, is a Poisson distribution. Okay. So once you do that, later on you can do the test statistic if you want. You can go find it, or you can go get the tabulated value, compare it, and say whether you are accepting or rejecting that. That is not part of this particular question. All right. Any questions till this particular point? Okay. Then comes the question that I believe most of you have been discussing about, the visualization. And before I take up this visualization, let me first clarify what was said in the very first week of this lecture. The purpose of a visualization is that I'm going to summarize the entire content. So the purpose of that visualization is to give you an insight without any analysis, or the analyzed insight in a second or something of that sort. That is the purpose of visualization. If you have to go and examine the visualization again, then the visualization is wrong. Okay. So the visualization should convey the meaning immediately. You should not go and analyze a visualization. Okay. Having said that, this particular graph, from this, when I look at it, immediately what I can see, as weight increases, my mileage is dropping. That is all. You cannot contest to me saying that because you have given me the colors, I will go and look at red is dropping, red is also dropping, green is also dropping, orange is also dropping. So for all model wise, it is reducing. If I wanted to convey the meaning that this was going to be model wise, what I should have done is, at least for this data set, I should have split it into different, let's say, graphs one after the other, same axes, it's fine, but graphs one after the other, so that I can clearly indicate that for each model wise it drops. If I do not do that, if I do not split this particular graph, then the message that it conveys is go analyze it further to find out what model does. So that is not the scope of a visualization. The purpose of a visualization is to give you the insight immediately, is to convey a meaning instantaneously. So this graph conveys the meaning instantaneously, that has weight increases, the mileage drops. Across models or not across models, for that you have to go and see where the values are lying. So this would have made sense. Let's say reds were all on top, then blues were on in the bottom, then you had yellows, then you had greens, so on and so forth. Then you can say model wise this graph is giving it to you. But for this data, if you want to do model wise, you will have to split the graph only. All right. So that is why the answer to this question is, it gives you the relationship between car weight and mileage. As car weight increases, the mileage drops. That relationship is given to you by this graph. There is no contention or any subjectivity involved in saying model wise the relationship between car weight and mileage is given, because if I wanted to convey that model wise information in this particular graph, I should have split it. Because if I want to do model wise analysis, I have to dive deeper into the graph, which is not the purpose of a visualization. Okay. Any questions on this one?
Sir, what you have said is fine. I just wanted to ask you one thing. Suppose if this wasn't the dots, right? It was suppose, let's say, lines, orange line, green line. Okay.
Okay,
and some
orange
other
line,
data.
green line.
May not be cars and weights, maybe some continuous data, right?
Okay.
Same graph, same numbers. Okay, but instead of having those dots, we are having lines, a blue line coming down, an orange line coming down. In that case, what will you call it? Is it model wise?
Okay. So when I draw a graph, all right, you can call it model wise, provided the graph, let's say, is not intersect, they are in parallel. If they are overlapping each other, then what will happen? You cannot see one color after the other.
Yes.
Making sense? So then you cannot say model wise. Here the graph is just congested. In fact, it will not even convey to you whether the relationship is linear, increasing or decreasing. I'll go one step further. It will not even convey whether the model is going down or up, because you need to show arrows. If you do not have arrows for your graph on a line graph, you cannot tell you whether it's increasing or decreasing. And in fact, that is why in most time series information or something of that sort, they always put an arrow where it is going, the direction in which it's moving.
Okay.
Making sense?
Science, if you have to call it a model wise, it is best. It has to be, separate graph. If you're calling model wise or whatever category wise, it has to be separate.
For this data, that is what I'm trying to say. If let's say there was a grouping, Reds were all sitting on top, blues were all sitting in the middle, greens were all sitting in the bottom. Then it's fine to use it because then you can say model wise, all red cars are always light in weight and have high mileage. Blue cars are mid-weight and have medium mileage. Green cars have low weight and have low mileage. Then that message is clear, conveyed by the same analysis.
Yes, yes,
Making sense? That depends on the data.
yes, sure. Thank you.
All right. Anything else? All right. So these were the questions, and before I hand it over to Srivatsa for the last three, what I would like to say is there was another other request saying that there were too few questions and the weightage was not even. It's very challenging in a course like business analytics to set questions which are not computationally intensive. All right. So these computations will become more and more intensive as you progress through the course. And we are focusing on, and given our platform is only, let's say, TCS Ion, where we can use MCQs, MSQs, and descriptive questions where you can enter and answer. We will have to consider the calculator because we did get a request saying that the calculators are difficult to use. So if I give you a highly computative problem and then give you more problems, you might run into the issue of lack of time. So that is why some questions have more weight. For example, this computation would have taken you some time. So we wanted to make sure that you see that the weightage of the problem, you see what is given, you identify the catch, then do the computation and get a result. And that is why there are weights, there is a high weightage for this mark, for this particular question. The reason why you are raising this point, I agree. If you get this wrong, then you lose a chunk of a mark. But that is where the learning comes into picture. You will have to make sure that this thing, you cannot just say that just because I lost mark in this high weight question, I enter the registration. Yes, that is how the system is designed this time. So you will have to overcome on that front. All right. So that would be my explanation. I will stop here. And Srivatsa, do you want to take over for the last three questions?
Can you keep sharing your screen? I will just explain what it is.
Yeah, sure. No problem.
So question number 7. So this is a direct application of the chi-square test of independence, which we had looked at. So we had looked at this multiple times during our earlier live sessions as well. And there was also a practice assignment question on this. So the first question is to find the expected frequency of Chennai people preferring brand B. So in that case, what you do is you go to that cell which has Chennai and then brand B, multiply the column sum and the row sum and divide it by the total. In this case, it is 328 into 412 divided by 1238. Right?
328 into 412 divided by the total. This number 1238.
1238. And you will get the solution for this.
So it's for question number 8, right?
Question number 8.
So this will be the answer.
And question number 9 is the calculated value of chi-squared. So this is very similar to that goodness of fit formula which was discussed earlier. So what you do is to have the observed minus the expected, the whole square divided by expected, and you sum it over all the 4 combinations, and you would end up getting an answer of 4.11. And we have been quite liberal with the range here. So any answer from 3.9 to 4.4 was accepted for this question. And finally, you will have to comment on whether you reject the null hypothesis or you fail to reject the null hypothesis. In this case, the calculated value happens to be greater than the tabular value. Therefore, you reject the null hypothesis and conclude that the categorical variables under consideration are not independent. So these are all straightforward applications of what you looked at in the practice assignment. So I think conceptually, this would have been easier for you, but it would have been computationally expensive, of course. And the final question again is the Bayes rule application. And this was again discussed earlier, where you had 3 machines and the percentage of defectives coming from each of these machines. And the question here is to find the probability that the product has come from a certain machine B, given that it is a defective. And you will obtain an answer from 0.32 to 0.36 in this case. So if you have any doubts or questions here, you can let us know now. In fact, this question has, I think, 10 marks weightage. I think it's not that difficult to solve, I think.
It's like the same question from the assignment.
It's the same.
Not the same question. I think the values have changed,
Numbers have changed,
Only
but
have
the
changed. Only one
but
value.
it's a direct application.
Yeah.
since it's your first quiz and yeah, since it's your first quiz, we made it a bit easy. But be assured, your final exam paper will be tough. We will be giving you a mark for the final exam, but that paper will be tough. So be prepared for it accordingly. Right. Okay. Anything else? Okay. If there is nothing else, then we will.
Can the pattern for the second quiz be expected to be the same as this?
What do you mean by pattern?
The number of questions, the level, etc.
Then
Because the syllabus is the same.
The syllabus is the same. We might push up the level a bit more, and maybe a few more questions added. That is all. But it will not be varying very differently from this pattern. It will be the same because, like I said, it's computationally intensive course. So, so we'll stick to a low number of questions with the high weightage for a few.
Okay, sir.
Sir,
Yes. Go ahead.
Venu here.
Yes.
Sir, I found this exam tough because I lost 20 points.
Okay.
And you're saying that the final exam will be even more tougher. So what steps in or how should I prepare to
Okay.
face that?
Okay, so solve the practice problems because, for example, this is a direct practice problem question. This is a direct practice problem question. So your practice problems set the foundation for your quiz, all right? And we will also be giving you a mock quiz for the final exam. Why the final exam will be more tough is the reason is that there are different topics that are going to come over there. Here we have only 4 weeks. The first 2 weeks is very easy as compared to the weeks 3 and week 4. Weeks 5, 6, 7, 8, and so on and so forth will be even more tougher and even more computationally intensive. That is why we are telling the final exam will be tough. For example, if we start asking questions from logistic regression, it will be tough, right? So we will be giving you practice problems. Do not worry about that. We will be giving you one mock. Do not worry about that. So there will be sufficient preparation on you. But if you want to prepare, focus on the practice assignments because that is where you will have more number of problems to solve. Apart from that practice, you should also go and follow some textbooks and solve those exercise problems or those numericals that they have given, right? We are acting as a guide to that course that we are giving you, but you should also have other sources to get more number of questions. You can't completely rely only on us. So that is what I would advise. Okay, Venu, is that fine?
Sure, sir. Thank you very much.
Sir, I want to know that where can we practice the scattered plot conclusive graphs? I mean, the question was in the quiz
one.
about, yes, this kind of questions, where can we find?
These kind of questions, it's actually difficult to find. You should construct it on your own. So do one thing, construct a data set on your own, plot it and put it in the discourse, and we will answer whether you have done it right or wrong. So that is how you should do. For example, this data set we created on our own for this purpose of this question, for this quiz, right?
So which kind of data set did you use? I mean,
no, we created we created cars, we put models, then we generated the weights for it from a distribution, and then we plotted it here. And then we asked you what is the relationship. Making sense? So these questions are created by us. This particular graph, in fact, is for the data for this is created by us, and then we give you only the graph. So this will not be available in any textbooks, predominantly in any textbooks. So you'll have to work around that. You have to understand it, generate it on your own. That is what I'm trying to say. So these questions, generate it on your own. Tell me, show me the Excel. Maybe plot the same graph in Excel. Sir, this is the meaning I'm trying to convey. Is it correct or not? And we will help you out. Yeah.
Okay, sir.
There is one book called Data Visualization. I forgot the author name. It's just, I forgot the author name. That author talks only about visualizations throughout this text. So you might find some data sets and some visualizations over there. That may be helpful. I'm not able to recall the author's name. Maybe I will put it just.
Is it Bishop?
Not Bishop. Some other name.
Okay.
Sir, put it on the discourse when you remember.
Do one thing. Just create a question and tag me. I will come there and I'll answer. All right.
Okay, sir.
So do that. I will put it up. I just searched for it. It's a female author. I will put up that textbook. So that should act as a good source for you to understand visualizations.
Sir?
Yes, go ahead.
Sir, there are like 5 suggested books for this course. So you mentioned practicing some problems of different topics coming in future weeks from textbooks. So is it possible to recommend 1 or 2 out of 5, or we need to refer all 5?
So to be very honest with you, I have not seen the textbooks as of yet. So I do not know what is recommended from the textbook. But when we say 5 textbooks, it's primarily because different topics would be in different textbooks that have been covered well. Shivan sir, do you have any idea of the books that are recommended?
So one point to add is, is Stein and Foster mentioned in the recommended textbooks?
I just shared it in the chat.
Yeah, so
okay.
So I think this will cover mostly the statistics part of it. For example, if you want to look at linear regression or logistic regression, statistics textbooks would help. But in addition, in this course, we are also looking at optimization, operations research, and then we will look at data envelopment analysis. So for that, you may have to refer some operations research textbooks. Right, so it will be a combination of.
Sweeney, it's given. Look, Anderson Sweeney is an operations textbook. So this is a good source for those topics, right? Statistics for business. Oh, this is a different book. It's not this thing. It's not quantitative models. Okay, so this is a different book, but this should also have some amount of whatever sir is talking about, right? Yeah. So these textbooks, it's fine. Like I said, each of these textbooks will have different topics that have been covered. So recommending one may not be possible. Yeah, recommending one may not be possible. For example, statistics for business and economics, this would have the regression from, let's say, from the perspective of elasticity that Sir talks, right? So that will be in one textbook, and some other textbooks might have, for example, this textbook, managerial statistics, will have it from the perspective of fitting a model for a data. So it is not possible to recommend one, since different topics are covered in different textbooks.
Okay, sir.
That is a challenge.
Sir, actually, I mean, even if you refer the PPTs, that serves the purpose to, I mean, to a lot extent, I think.
Yes, because sir does answer it in a lot of technical sense, correct?
Sir, actually, now I was looking for those 2 PPTs of week 2 and 4. They are not yet available.
Which one?
Week 2 and week 4.
Which is not available?
They are not available on the portal yet.
Which is not available?
Both, sir.
No. 2 and 4 of what? What and 2 and 4 is not available?
Week 2 and week 4 of business analytics, the PPTs.
The PPTs, the deck is not available, is it? Okay, we will look into that. We will ask sir whether it can be shared, and we
actually that question of the very first question that demand, right? Actually, I didn't, revise that formula, and in exam I was like watching the formula. When I came back, I was searching for it, and then I thought, oh, the PPTs are not there. So I went to the video, and then I So
Okay.
it becomes very difficult to revise. At least if you have some material at the last
Right.
minute.
Fair enough. We will. I will speak to sir and we will upload it. All right.
Yeah.
But
Thank
this formula is very intuitive to get.
Yeah,
Right.
actually, I made a silly
It is the
mistake there.
slope by dB minus the
Yeah, but
value.
at least looking the formula, just before the exam helps.
No, I agree. But okay, one thing that I might recommend is, since you have taken a business analytics course, there will be a lot of formulas coming. So
Okay.
it will be at least in the future. If not in this course, at least in the future. So it will be better if you are able to derive a formula.
Exactly.
We will not talk to you about the derivation in this course, but that is the back end work that you have to do.
The intuition should
Because
be.
intuitively you should be able to derive something. If you do not believe on that, and if you want to remember all formulas, it becomes very, very difficult.
I understand.
Very, very difficult.
And sir, one more thing I wanted to know, because what we used to do in BDM is there was a lot of practical with Excels and all. Okay, what is going to be in business analytics in coming weeks? Is it more like Stash2 where we have to do computations and all by our own, or they're doing more practical things like we did in BDM?
We are doing it in parallel.
Okay.
In BDM, it was you are given a data set, you do all the steps on the data set.
Yes.
Here it will be slightly different. We will be talking to you in terms of the technicalities. Like, let me take an example of the next week content that is coming to you as logistic regression, right? Sir will actually show you how to build a logistic regression model on a data set in Excel.
Okay.
Right? So that will be explained in detail, and he will go into the details of what does it mean, how do you do the formulas, so on and so forth, right? But he will not go into the detail of, let's say, optimization piece. You will understand what I mean when you look at the video. You will have to find the coefficients using optimization. Sir will not discuss that. That he will leave it as it's been covered somewhere else. But that is what he will show you. And in the tutorials, we will tell you how to fit that model, how to fit a logistic regression model for a larger data set in Python. So that is how this course will be. And then how to interpret the results. The entire focus of this course is, this is the model. You can fit it in, let's say, these kind of ways. But what does the output tell you? So that is the main purpose of this course. The technique with a data instance, what is that output all about? That is the focus of business analytics. That's why it's business analytics.
Okay, so sir, for example, if you do, let's say, linear regression or let's say logistic regression, right? So here we are doing it in Excel. So do we need to know all that loss function and everything that what we are doing in MLP and MLT?
No, we are going at a basic level. We are focusing only on how do you fit a model, how do you get the what is the sigmoid function, all of that. So I would say.
Okay, mostly the application and the interpretation of the
application and interpretation.
Okay, thank you.
Okay, Swami, maybe you can take over. I will stop here and we'll take any more questions towards the end. Swami and Shivata. Do you guys have any questions regarding the assignment? Like I said, we will not solve the assignment questions. We'll only guide you. Yes, go ahead, Kiran.
Good evening, sir. So I had a doubt in the graded assignment, like in the options given, there were the options for the parent distribution, which we needed to identify, were Poisson, binomial, geometric, and uniform. So, and when we run the PP test and the chi-square test, so, and the data given is also like 10 data points. So that was first part of my query, like it was a discrete data set. So can we fit a normal distribution to it? And the PP tests and chi-square are actually qualifying for the normal thing, and which is not in the option.
Okay, one second.
Okay, so I got your point. So the idea is to make it more challenging. So that's why we have selected a data set which has a few data points, and the variance is also large. So I recommend you to revisit your assumption or guess that you've made on the distribution. So you say that you run a chi-square test of, goodness of fit for normal distribution. So try doing it for other distributions as well. So as we guided you in the tutorials, start with the descriptive statistics. Also then do the visual inspection, plot histograms. So you might have two modes or bimodal, so things like that. So the answer to your question is revisit your assumption on normal distribution.
Sir, does that mean that it is possible for a distribution to fit into a certain, like suppose in this case normal, and actually the distribution might not be normal?
Possible. Here we have not given you normal. So we have not given you the option of normal. We have given you 4 options: Poisson, binomial, geometric, uniform. So why don't you try something within these 4?
Sir, the Python programs we have, which we were told that we would not have to code for these things.
Yes,
So we
yes,
can
yes,
only-
certainly.
So,
we have given you codes for separately for Poisson, separately for uniform, right?
yeah, but we only have for 2. We do not have
Yes,
it for
yes.
geometric or.
So you have come close
binomial.
now. So you have come very close now.
But both of those, I have run it for my data set on both of those, but they're not qualifying.
Oh, okay.
Yes, sir,
Okay.
and I also
I-
ran them on uniform
I-
distribution,
I-
and but they are not really fitting to that. And
Okay, okay. So if it doesn't fit, what does it mean? So the parent distribution is not Poisson. So you can have that assumption. You can have a null hypothesis saying that it is uniform or Poisson or binomial, and say you can reject the null hypothesis that, well, the parent distribution is not this.
And what if the histogram is not actually conforming to any parent distribution?
Histogram may not, no, because you are telling me that there is only 10 data points.
Yes,
So,
yes.
so I'm giving out
So-
the answer.
So actually, this is a classical example of bias. So you have seen the tutorial, so you have registered the steps. You want to accept the null hypothesis all of a sudden. I mean, right away. So that's not the case here.
So even in the tutorial, we said we follow this approach, but to confirm, we need the test. You can assume anything from the. In fact, the purpose of a visualization or the histogram. Let me put it very clearly. The purpose of the histogram is to narrow down. But if you do not have sufficient data points for narrowing down from the histogram, then you'll have to go check for everything.
Yes.
Correct. So,
sir, actually, in my case, I ran the tests on 3 distributions. Like Poisson also ran. I ran the test. Normal also, I tried it out, and uniform also tried it out. But
Okay.
none of these are fitting in.
just
Okay,
check
so
whether
here-
you have done it correctly. That
Yes,
is
yes.
one thing.
So I think he is heading in the right direction. So first of all, based on the descriptive statistics, you guess a distribution. So that distribution will be very evident because we have given you enough clues. So check the descriptive statistics, check the histogram.
Sir,
Yes.
the question specifically states that we have to guess the parent distribution using the histogram.
Yes, yes. Look at the
So-
histogram, see them, and guess the distribution. That is all.
That is a guess. no?
We have not studied any distribution, I think, which is bimodal, as far as I remember.
Arey.
It's okay. So
Okay,
we
try it out.
wouldn't.
Try it out.
So
Try
we
it out.
wouldn't test you anything that is not covered in
Not
this
some-
lecture.
yeah. So,
So, I
you
mean,
don't
I'm
have to
very
worry about
happy.
bimodal. Yeah. In fact, when I saw I didn't see the data set.
Hmm.
And I saw the question, I was actually very happy that someone is thinking about bimodal distribution. But okay,
Yes.
it's actually good. It's
You are
challenging
actually
question.
going very deep into this. I'm really happy that you're thinking in the right direction.
That was A2K, I believe, or A21K.
Yes, sir, AK21.
AK21, yeah. Okay. So good enough. You are going in the right direction. We can't give you more than this now. Guess it from what you see. From what you, in fact, use this. Guess it from what you see and what you have. The options that you have and what you see in the histogram. Try to match both and make a guess. Okay, it's just a guessing game.
Okay, sir.
All right. So I think for the assignment, there were 2 things. One is goodness of fit. Other one is chi-square test of independence, I guess. So anything else? Any more questions on the topics? These 2 topics?
Sir, and is there a way, like I had studied about bootstrapping and all, but we really can't do that, right?
Don't do
See.
bootstrapping. That is beyond the scores. So we're not discussing. In fact, that mistake was made by me. I told him how to generate. You can't do bootstrapping for this sample also. 10 data points, you can do bootstrapping, but do not do it. It is not meant for you. It's not at this level.
See, the idea is
not
not-
focus on it. Yeah.
Yeah, the idea is not to trouble you with all these things. So the idea is there are some data in the industry, in the real world, where your chi-square goodness of test might even fail. So every time you may not get vanilla data sets that will directly pass the chi-square test of independence or chi-square goodness of fit. So here we have tried to give you a data set where you can even reject the null hypothesis, or it could be even accepting the null hypothesis and so on. So you're going in the right direction. Let's see, wait for 2 more days. We'll give you the solutions for the assignment.
Sir, and can we try out entropy and all?
Not needed, don't.
Not needed, won't complicate.
Keep to the syllabus.
Yes.
Yeah, do not go out of syllabus.
Okay,
Sir,
sir.
one more doubt I have.
Go
In
ahead.
the assignment questions, there are 2 separate questions to check whether the null hypothesis is satisfied, one according to the chi-square value and one according to the p-value.
Yes.
So is it possible that the 2 contradict each other?
No, it
Mostly
is
it
not
will
possible.
It will not.
Okay.
So mostly, I mean, it never.
No, it will never will. Yeah, I should not have used mostly. It will never will. P-value and chi-square will both tell you the same thing. I should not have used mostly. Correct. So, sorry, Shivatsa. Don't get angry. Yeah.
I think we have given enough hints for the assignment.
We've given away a lot of stuff.
So we'll wait for 2 more minutes. If there are no more questions.
This
we can-
11th question.
Okay.
Okay, from the assignment that says in the chi-square goodness fit between the observed and expected data, what p-value did you get? Okay, so here which distribution we're talking? I mean, they just say, for example, if I'm trying with, let's say, uniform and then I'm trying with Poisson, so I mean, which is this? I mean, which I have to enter.
Your chi-square goodness of fit test is independent of the distribution that you're checking for.
Okay.
It only depends on your significance level and your degrees of freedom. It does not depend on what distribution. The parent distribution could be normal, uniform, Poisson, geometric, binomial, whatever. The procedure is the same, and the chi-squared value that you get and the way you get the p-value and way you get the tablet value, all of it is independent of that null hypothesis.
Okay, fine.
When I say independent,
isn't degree of
yeah.
Isn't degree of freedom dependent on the type of distribution we are testing?
Not necessarily. No? You can, okay, for uniform, you're telling we are splitting it equally. It need not be, because all of your computations will automatically change based on your end. So if you're considering 3 bins, appropriately your expected frequencies will change. If you're considering 5 bins, appropriately your expected frequencies will change. And hence, the thing will also change. No? Your chi-square value will also change.
So one more hint, let me give you. Check if the distribution is symmetric or not. that will answer most of the questions.
That give away the answer.
In that question, I would say, what is, I mean, for symmetricity, we have to check that mean and median are almost equal, right?
Yes.
So what extent we shall consider? I mean.
Okay, I get your point. Even this question was there on the discussion forum. So
Yes.
maybe in the tutorial, in the data sets that we showed you, we had a lot of data points and the variance was not that high. So therefore, you might get 4.94 and 5. So these are very close. So do not expect that here. So you might have little more difference between mean and median because the variance is high and the sample points are also pretty low.
So you mean to say that the difference shall be a bit greater?
A bit greater, not too great, a bit greater.
Okay.
Okay, so enough hints. I think the next step is to solve the assignment.
I got that.
All right.
So if we have some more time, can we look at the practice assignment for week 5 and 6 maybe?
Okay, you can.
I think there are only a few questions, so maybe we'll look at 5, and if your time permits, we'll look at practice assignment 6.
Sure.
Malanan, can you give me access to share screen?
1 second. I cannot do it. Yeah, for team, can you please make Shivatsa as a co-host?
Malolan, you can share the screen because you are the co-host. Srivatsa cannot.
That's what I'm trying to say. If Srivatsa wants to solve it, just give me 1 minute. Let me just load up the course on my screen. Then you want to load it for
week 5.
so week 5. Segment. Let me just share my screen. You're able to see the screen?
Yeah, I can see the screen now. So in week 5, the first question is you are given a primal of a linear program which has a maximization objective subject to 2 constraints, and there are 2 variables which are greater than or equal to 0. Now, what we have said is the dual variable corresponding to the first constraint is y1, and the dual variable corresponding to the second constraint is y2. So after solving the primal, then you find x1 star and x2 star, which are the optimal values of x1 and x2. And you find that x1 star plus x2 star is equal to c, which is the right-hand side of the first constraint. And the second constraint is not an equality, and you have some slack in there. So now the question is, what is the value of y2 star, right? So if you had looked at the lectures, this would be a straightforward question. Since there is some slack capacity or resources available with you, y2 star will be 0, right? Since you have it already, you are not going to go out and purchase that resource. Therefore, y2 star is 0. And the next question is, you have implemented a simple linear regression on a constant elasticity model with the following formulae after performing a log-log transformation. So when you perform a log-log transformation, that constant elasticity model will turn into ln of demand equal to ln of constant minus epsilon into ln of that price, right? So if you consider what is the value of C and you have a linear regression model in there, what will you do? You will equate ln of C to 100 because the intercept is 100. And if you take the exponential on both sides, so e power natural logarithm of C will become C, and the intercept value is 100, so it will be e power 100, and therefore the value of C is e power 100. And similarly, if you look at epsilon, in this case, epsilon will be minus 50, right? Will be minus 50. And the final question is to look at maximizing the revenue given a demand equation, which is 100 minus 4 into P. So the revenue is demand into price. And what you do is you find the first derivative of revenue with respect to P and equate it to 0 and find P star. And what is P star here? So you first, if you multiply, you will obtain 100P minus 4P square. And if you find the first derivative, you will obtain 100 minus 8P equal to 0. Therefore, P star will be 12.5.
Shriyata, let me do one thing. Let me write it down. Maybe it might not be able to be possible to follow it on the thing. So let me just write that down over here. Right. So what we are trying to say is dP is equal to 100 minus 4 into P's, right? So this is your demand. So revenue is nothing but demand at price P into the price that we send it. So it's going to be 100 minus 4 into P into T. So if you want to maximize revenue, whenever we want to maximize, let's say a particular function, we differentiate it with respect to our variable. So if we do that, this will become 100 minus dou by dou P of 100 into 4p squared, right? So that will be 100 minus 8p. So your p is going to be 100 by 8.
Yes. So P will be 12.5 in this case.
Yeah, this is I-
It will be 12.5.
So that will be your answer for your P star.
Thanks, Malalan. And the next subsequent question is, you still don't know, you have found the first derivative and found P star. You still whether you're at the maximum or the minimum. So when you find the second derivative of this, that is Rp with respect to P, what you will obtain is a negative value. So what did you have here? You had 100 minus 8p was the first derivative.
So dou by dou P of
Of
R is equal to 100 minus 8p. So dou R by dou squared P, I believe that is the notation, that will be 0 minus 8. So you get a minus 8.
Minus 8, yeah. And therefore, you conclude that the revenue function is concave. Do you have any questions on this practice assignment?
Week 5.
So, if not, can we move to week 6 maybe?
We will stop here, Shivatsa, because it's
Yeah,
only
sure.
5 more minutes left. We'll stop here and we'll pick up week 6 next week.
Yeah,
We'll
sure.
do week 6 and 7 together. There will be a slight delay in week 7 practice assignment. So please hold on. It will be up by Wednesday, all right? We are just creating it and we'll put it up for you guys to solve by next Wednesday, maximum. Okay. So that is all from us. Any questions from anyone? Right. So if there are no more questions, we can wind up. Thank you for joining. Have a nice week. Solve the practice assignment. And, yeah.
Thank you,
Thank
sir.
you, Shivatsa. Yeah, thank you, Shivatsa.
Thank you.
Swami.
Thank you, sir.
Thanks, everyone. What time we can end the meeting?